Do you know the difference between an end turn and a tool use stop reason? Can you architect a multi-agent system that doesn't leak context? Welcome to our practice exam series for the Claude Certified Architect Foundations. Today, we're hitting Domain 1. This is the core of the exam, focusing on how Claude thinks, acts, and orchestrates complex workflows. I have 10 exam-style questions ready for you. Let's see how many you can get right. Question 1. You are building a resolution agent that must use lookup order followed by getShippingStatus, which is the most reliable way to implement the loop control flow. A. Terminate the loop only when the assistant message contains the text. Here is your info. B. Use a post tool, use hook, to check if the tool output is a JSON string, then stop. C. Continue the loop as long as stop reason is tool use, and terminate only when it is end turn. D. Use prompt caching to ensure that the loop terminates automatically after 5 minutes of inactivity. The correct answer is option C. This works because the agent is telling you exactly what it wants to do next. When it returns tool use, it's a clear signal that another tool call is needed, so the loop should continue. When it returns end turn, the agent is done reasoning and the task is complete. That makes the whole flow predictable and easy to control. Option A doesn't work well because it relies on specific wording in the response, and natural language can change from one run to another. Option B also falls short because getting a valid JSON response only tells you the tool worked, not that the entire task is finished. And option D misses the point entirely. Prompt caching helps with performance, but it has nothing to do with managing execution flow or stopping an agent loop. Question 2. You have a coordinator managing a search subagent and a synthesis subagent. How should the synthesis subagent receive the findings from the search subagent? A. The subagents should share a global memory buffer, so the coordinator does not have to pass data. B. The coordinator must explicitly include the search findings in the prompt when calling the synthesis subagent. C. Configure the subagents to use cross-region inference so they can see each other's outputs in the cloud. D. The search subagent should use a webhook to post data directly to the synthesis subagent. The correct answer is option B. In a well-designed agentic system, the coordinator acts as the single source of truth by explicitly passing the search findings when calling the synthesis subagent. You maintain full visibility, controlled context sharing, and clean separation of responsibilities. Each subagent gets exactly the information it needs, no more and no less. Option A creates problems because a shared global memory removes isolation and leads to context mixing, which makes the system harder to reason about and debug. Option C is incorrect because infrastructure features like cross-region inference do not magically enable agents to share outputs or coordinate execution. And option D breaks the orchestration model entirely by allowing subagents to communicate directly, which hides failures, bypasses retries, and removes the coordinator's ability to manage the workflow. Question 3. The coordinator needs to start 3 search tasks at the exact same time. What is the correct way to trigger these parallel tasks? A. The coordinator must emit 3 separate task tool calls within a single response turn. B. The coordinator must wait for the first subagent to finish before spawning the second to avoid a 429 rate limit error. C. You must use the fork session command to split the coordinator into 3 identical copies. D. Set the top K parameter to 3 to force the model to pick 3 different search tools. The correct answer is option A. In an agentic system, parallel work is created by issuing multiple tool or task calls in the same coordinator turn. When the coordinator emits 3 task calls together, the runtime understands that these tasks are independent and can be executed concurrently. This is the clean, explicit, and supported way to achieve true parallelism. Option B reflects a common misunderstanding. Rate limiting is not solved by forcing tasks to run one after another. Doing so removes parallelism and slows the system without actually improving reliability. Option C is incorrect because cloning the coordinator duplicate state and breaks the single point of control that orchestration depends on. And option D confuses model sampling with execution logic. The top K parameter influences how text is generated, not how many tasks are launched or when they run. Question 4. A user is angry and demands to speak to a manager immediately. Question: how should the agent perform a structured handoff to a human? A. Just stop responding and hope a human notices the empty end turn. B. Provide a summary including customer ID, root cause of the anger, and steps already attempted. C. Send the human agent the logit bias values to show how close the AI was to a solution. D. Use a system prompt instruction to never give up until the user says thank you. The correct answer is option B. A structured handoff is not about stopping the AI. It is about transferring responsibility with context. By providing the customer ID, the reason the user is upset, and what has already been tried, the human agent can step in immediately and continue the conversation without friction. This reduces frustration and shows professionalism. Option A fails because silence is not a handoff. Without context, the human agent is left guessing, and the user feels ignored. Option C misunderstands what humans need. Internal model signals like logit bias have no meaning outside the AI system and do not help resolve customer issues. And option D is dangerous in escalation scenarios. When a user explicitly asks for a human, continuing to push the AI response increases frustration and damages trust. Question 5. Your read tool returns code with tabs, but your write tool requires 4 spaces. Question: where should you handle this conversion? A. Use a post tool use hook on the read tool to normalize the code format before Claude sees it. B. Use recursive character text, splitting to break the code into chunks until the tabs disappear. C. Ask the user to manually reformat the file before the agent proceeds. D. Use a pre-tool use hook to increase the model's temperature so it imagines spaces instead of tabs. The correct answer is option A. When a tool returns data in a format that does not match downstream requirements, the fix should happen at the boundary between the tool and the model. A post-tool use hook is designed for exactly this purpose. It allows you to normalize, clean, or transform the tool output before the model reasons over it, ensuring consistency and preventing formatting errors later in the workflow. Option B misunderstands the problem. Splitting text changes structure, not content, and it will not reliably remove tabs. Option C defeats the purpose of an autonomous agent by asking the user to fix an issue the system should handle automatically. And option D confuses creativity with correctness. Temperature influences how imaginative the model is, but formatting rules like tabs versus spaces must be enforced programmatically, not guessed by the model. Question 6. You need to refactor a 5,000-line legacy file. Which decomposition strategy minimizes attention dilution? A. Read the entire file into the context window once and ask for a full refactor. B. Use a fixed sequential pipeline prompt chaining to refactor 10 lines at a time alphabetically. C. Use an adaptive plan. First map dependencies, then refactor logical modules as separate tasks. D. Set the max context window to 200,000 tokens and use Opus to handle the load. The correct answer is option C. Attention dilution happens when a model is forced to reason about too much unrelated information at once. The smartest way to avoid this is not by increasing context size, but by reducing cognitive load. Mapping dependencies, first, gives the model a mental map of how the system fits together. Refactoring logical modules as separate tasks then allows the model to focus deeply on one responsibility at a time, producing cleaner and safer changes. Option A fails because dumping a massive file into the context spreads attention too thin, causing the model to miss important details. Option B looks structured, but it ignores how code actually works. Refactoring by alphabetical order or fixed line counts breaks logical cohesion and leads to inconsistent results. Option D is a common misconception. Larger context windows help with recall, but they do not eliminate attention dilution. Reasoning quality still degrades when too many unrelated elements compete for focus. Question 7. You are investigating a bug. You want to see if the bug exists in version A and version B of the code. What is the most efficient SDK feature to use? A. Resume the same session and just upload version B on top of version A. B. Use fork session to branch from the initial investigation into two separate paths. C. Use prefill to tell the model the bug is definitely in version B. D. Start a new session and use retrieval augmented generation to find the bug. The correct answer is option B. When you are comparing two versions of code, the key idea is to preserve shared investigation context while allowing independent exploration. Forking the session does exactly that. You start with the same understanding of the problem, then branch into two parallel paths where you can test version A and version B independently. This makes comparison clean, efficient, and unbiased. Option A causes problems because reusing the same session blends the two versions together, making it difficult to tell which behavior came from which version. Option C is risky because it injects assumptions into the investigation instead of letting evidence guide the conclusion. And option D is inefficient because retrieval tools are designed for pulling in external knowledge, not for structured version comparison, and starting a new session throws away valuable context. Question 8. An automated agent is reviewing a pull request. It keeps looping because it is unsure about a specific line of code. What is an anti-pattern for stopping this loop? A. Checking for stop, reason end turn. B. Setting an arbitrary iteration cap, for example 10 loops, as the only termination mechanism. C. Using a post tool, use hook to validate the model's tool calls. D. Implementing a human in the loop approval gate for write actions. The correct answer is option B. Using a hard iteration limit is an anti-pattern because it does not address why the agent is stuck. It simply forces the loop to stop after a certain number of tries, regardless of whether the reasoning is progressing or completely broken. This can mask design flaws and lead to unpredictable behavior. Option A is good practice because it listens to the model's own signal that it has finished reasoning. Option C helps prevent repeated or invalid tool usage, which can actually reduce infinite loops rather than cause them. And option D is a deliberate safety stop. When an agent is uncertain or performing risky actions, involving a human is the correct and responsible choice. Question 9. The coordinator agent becomes overwhelmed and starts giving vague instructions to subagents. What is a common risk in hub and spoke architectures? A. Subagents will start communicating with each other behind the coordinator's back. B. The coordinator might use overly narrow task decomposition, leading to incomplete research coverage. C. The token tier will automatically downgrade to haiku if the coordinator gets confused. D. The model will hit a recursive depth limit if it thinks too hard. The correct answer is option B. In a hub and spoke architecture, the coordinator is responsible for understanding the problem and breaking it into meaningful tasks. When the coordinator becomes overloaded, the most common failure is not rebellion or model limits, but poor task framing. Vague or overly narrow decomposition causes subagents to miss important angles, resulting in incomplete or low-quality outcomes. Option A describes a violation of the architecture rather than a risk inherent to it. Option C is incorrect because model tiers do not change automatically based on agent behavior. And option D is a myth. There is no depth limit that triggers simply because the model reasons deeply. Question 10. You are defining a search subagent. Which of the following is not part of an agent definition? A. System prompt. B. Description of the agent's purpose. C. The subagent's personal credit card billing limit. D. Tool restrictions. Which tools the subagent can use? The correct answer is option C. An agent definition focuses on how an agent behaves, what its purpose is, and what tools it is allowed to use. Elements like the system prompt, the agent's role, and tool restrictions directly shape how the agent reasons and acts. Billing information has no impact on agent behavior and belongs to platform or account governance, not the agent definition itself. Option A is incorrect because the system prompt is a core part of defining an agent's behavior and boundaries. Option B is incorrect because clearly stating the agent's purpose is essential for predictable and focused operation. And option D is incorrect because tool restrictions are a key part of controlling an agent's capabilities and enforcing least privilege access. And that is our deep dive into Domain 1. We've covered the heartbeat of Claude's autonomy, from mastering the agentic loop and stop reasons to designing sophisticated hub-and-spoke architectures. Remember, as an architect, your success isn't just about writing the code. It's about how you manage the flow of information between agents. In the next video, we're going to put your knowledge to the test with 10 practice questions focused on Domain 2, tool design, and MCP integration. I'll see you there.